So the next three of the final three talks will be more on spatial statistics. So first is Robin Lovelace, who will be talking about active transport planning and using a cycle network. This has included some work for public authorities over time. Last year you were involved in a fairly nerve-wracking publication of a cycle network planning app, which I'm not sure whether we'll hear about that, but it seemed quite nerve-wracking at the time because the amount of data involved was very large. Okay, good.
So, is that mirrored? Yay. I feel a bit like Madonna wearing this. I don't think I've ever worn one. So, hello everyone. I'm Robin Lovelace, University of Leeds. I'll be talking about what we call geocomputation for active transport planning. And if you came to our workshop earlier, could I get a show of hands if anyone came to our workshop? You'll know that geocomputation just means handling geospatial data with an emphasis on creativity and kind of data science and reproducibility. In this talk, I'm not going to be talking so much about those underlying methods. This is a great opportunity to talk about the application and to really think about why are we doing this? What's the purpose of using all this amazing technology that we have? And I'm going to be looking at one particular application, which interestingly you don't see much in the R world. You see a lot on biostatistics. I've seen plenty of talks on kind of marketing stuff, but I'm really coming from a transport background. And transport is an inherently spatial activity. So by very definition, transport involves moving from point A to point B. So therefore, I find it surprising that so many transport analyses don't involve spatial data. R is appropriate language for dealing with spatial data, and it's great to be able to present my work here. So thanks, everyone, for the invite, and so far it's been an amazing event. I've got three parts to my talk, so fairly simple outline. I'm going to propose a problem, then propose a solution, and then find problems with that solution. And then this is where R can help. Okay, so nice, simple structure. And the idea is we've got something wrong with our transport system represented in this GIF. And hopefully R, if used in a correct way, can help resolve some of these problems. Can I get another show of hands who attended the Jeroen's talk about Rust? Anyone? Okay, keep your hands up if you've actually tried that Rust package. Okay, one person. So I did, and I am super impressed at this guy because I mentioned it to him yesterday evening, and I said, oh yeah, I found an issue because it doesn't give you a timing runner when you set it running on a big video. You don't know how long it's going to take. Little do I know, when I wake up in the morning, he's like, oh, I fixed that bug. And now it's got a percentage tracker on it. So a lot of these GIFs are inspired by that GIFski package. And I'm going to show this in the next slide. Anyway, who am I? I'm an environmental geographer, which means that I don't see a particularly strong divide between the kind of human data and physical data. I believe geographic data can help integrate these two, and that has huge policy implications. I learned R doing a PhD on energy and transport, and now I work both in an Institute for Transport Studies, but also in an Institute for Data Analytics. So I'm kind of at this multidisciplinary interface using new software to try and solve some really interesting problems. And I think it's really great when people go from one discipline into another and realize that their skills can be useful. I also really like tech, so I don't expect you to read that, but that's some code. And if you've got a program called YouTube DL installed on your computer, it will generate this little GIF, which is actually me. So I like researching cycling, but I also like riding a bike. Unfortunately, this talk isn't about that kind of bike riding. It's about bicycle riding for everyday transport, which brings us nicely on to the problem. The problem is quite clearly stated in this image. It's a highly congested city, and this is something that affects many cities around the world. You've got congestion, so you're wasting time stuck in traffic. You've got air pollution, and many kind of environmental, social problems associated with congestion. In addition, we can look at data to try and understand this problem better, and I know that this slide isn't coming out very clearly, but this is from the IPCC's assessment on climate change, which shows transport is the fastest growing source of emissions in many countries. And I find it surprising that there's so little attention on transport energy use. Often energy research is very focused on electricity production. So I think this is a really interesting area of study from a climate change perspective. And it's a problem because people like to travel. We all travelled here. I took a plane from the UK. And the interesting thing is, as you get more money, statistically, you don't have like an upper limit of travel. You see some business CEOs travelling like 10 times a year or 20 times a year. And it's also very difficult to decarbonize, which is represented by the GIFs there, that you cannot create a flying car, for example, or more prosaically, electric cars also require a huge amount of resources to manufacture. So I don't want to focus on the problems. I want to focus on the solutions. How can we actually resolve these problems? And actually, it's pretty simple, and it looks a little bit like this. And I'd like to point out that this photo here is in the Netherlands, which is the same country that this photo is from. There's just a big time difference. So what happened in the 1970s in the Netherlands, there was a huge investment in infrastructure for walking and cycling, and now it has the highest level of cycling in the world. It has a very low level of obesity, and it has very positive health outcomes. So for everyone, how can we make cycling available for everyone? That's a political problem. That needs to be solved through politics. And that's something that R really can't help us with. But we have another problem from a technical side. If you're looking at this problem in terms of technology, in the 1970s, the main problem was that they had too little data. In today's age, we have a complete data deluge. There's so many data feeds coming in. And I've spoken to a lot of people who are transport planners working in local authorities, and they say, we've just got too much data and we don't even know how to read it in, let alone make sense of it. So the problem there is data overload, which brings us on to solutions. And I was going to talk just about solutions in general, but I've made this specifically about technical solutions because I think the political solution is for another day. And the first thing that you can do is simplify the data. This represents the city of Seville in Spain, and it's got multiple layers of geographic information, but it's crystal clear. Even on the low-resolution screen you've got here, you can just make out a cycling network. And this is a real cycling network, so the black lines are the core network, and the dotted lines here are the parts of the route that were added on subsequently after the core network. And there's about 200 kilometers of cycling infrastructure here. So it's not actually a huge network by Dutch standards. But this network has led to massive increase in cycling across the city of Seville. So this shows that you can do it and that you can understand the solutions by simplifying the data deluge. And one example that I have of this, okay, maybe I don't. An example of this kind of technical solution is the propensity to cycle tool. And this is essentially a web application that is based on Shiny that Roger mentioned, and it was funded by the UK's Department for Transport. And what it does is it provides a solid evidence base that is the same across all of England for all of the local authorities to help decide where to invest in cycle infrastructure. So this is just one region, and transport decisions are generally made on a region-by-region basis. So, and partly for computational time, we split the country up into different regions. So going back to David Smith's talk, if we wanted to run this in parallel, you'd probably want to run each of those regions in parallel. And you can see, essentially, the data visualization shows you that, essentially, there's very low levels of cycling. Red means 1% cycling, essentially. So we live in a bit of a cycling desert in West Yorkshire, which is what this region is. And the great thing about modelling and statistical modelling is that you can use it not only to try and predict past events, but if you have a good model and you can justify your assumptions, you can imagine how the future could be. So what I'm representing in this particular scenario is called Go Dutch scenario, and this represents what would happen if we got to the Dutch levels of cycling that were represented in one of the previous images. And how do we do that? Just to drill down to another layer of data, and I'm going to try and zoom in a bit so you can actually see some of the user interface here. So there we go. You can hopefully see now you've got different panels here, and I'm just going to click on straight lines. This is a conference about R, so hopefully you're all into data. And this shows you the level of data that we're using for the model. This is called origin destination data. And simply by putting it on a map, you can gain new insights into it. You can even get estimates of how much CO2 you'd save, what are the health benefits, if people who are currently traveling by car along the routes represented there switched to cycling, or you could use the same method to look at walking uptake, what would be the benefits in terms of health? And without going through the whole story of visualization, to cut to the chase, I'm going to remove the zones, and I'm going to click on this drop-down menu, and I'm going to click on the route network LSOA level. So in the city of Leeds, there's about 10,000 of these OD pairs. At the LSOA level, that has a fourfold increase in geographic resolution. So in terms of origin-destination pairs, that's a 16-fold increase in the number of data points represented. And then it becomes difficult to visualize. But what we've done is that we have routed every single one of those 4 million routes all across England, put it on the road network, and we did some geocomputation to create a raster image that represents what that could look like if those cyclists were to use the road network. So this thing scales, and if the internet connection holds out, I can even move down to the most densely populated part of the UK, which is obviously London, and you can see that you get quite a dense network of cycling infrastructure in London, some of which they are actually building now with the cycle superhighway. So this is really exciting. The problem is that while in London they have a team of dozens of data scientists and other technical people, in other parts of the UK, they just lack the technical skills. So we've provided a baseline for people to make decision-making. And ultimately, this is about evidence-based decision-making. So not only is the basis of this tool open source, all of the data is provided to the local authorities and to academics. So I'm just downloading a 2.5 megabyte GeoJSON file to represent this. So really, this is a great example, I think, of how you can use technology to assist in what is initially seen as a political problem. You can use data, when visualized appropriately, to tell a story that can have an impact. Okay, so the next part of the problem is the infrastructure. I've shown a method in very broad terms to estimate cycling potential, but when you start drilling down into that problem, and when you speak to local transport planners, they say, okay, we've got these cycling networks, but number one, where do we build them? Well, that should be clear from the previous application, but what do we build where? And that brings us on to the most recent tool that we've developed for the Department for Transport, which is called CIPT, which stands for the Cycling Infrastructure Prioritization Toolkit. And we were lucky in this case because we didn't have to decide what to build in each place. The Highways England has a series of criteria, including road traffic volume, road traffic speeds, number of cyclists using it per hour, and we basically developed an algorithm. We implement their rules and put it across the street network in the UK. I'm not going to do a live demo. Also, it's password protected because UK Government Digital Services has a series of requirements that we need to meet before it can be publicly accessible. But that's the next stage of this. So I'm kind of doing this talk in reverse order. I'm showing you what we've done, and then I'm talking about how R can help or how R helped with this. So I just thought that I would demonstrate quickly what was available before we developed the propensity to cycle tool. And I know that Transport for London was mentioned by someone earlier, and this shows the TfL's tool, which was a good tool that scaled to the city level. But there's some issues with it. Number one, it's very specific to London, so it's very difficult to take their method and apply it to Leeds or any other city. And also the software license is unknown, so we don't know. Even though it's publicly funded research, we don't know what the license was. Just to provide another example, has the screen gone dead on yours also? Oh. I'll try reloading it in another tab. Yeah, so that was the previous one. Blame data table, which is the package that's doing that. Before that crashes again, I'm going to move swiftly on to the next slide. But basically, that demonstrated that tools previously only operated at a single city level and that they didn't have reproducibility built in. They were implemented in something like ArcMap. And when I asked people, can I see the code? There was no code. There was just a method that worked for one city. And R, I think, is an excellent way of ensuring reproducibility. And I've got one live demo. It's nowhere near as hard as Roger Bivan's live demo where he ran R version from the 1997. So hopefully, using R 3.44, because I still haven't upgraded, I'm going to be able to run this mini Shiny app that I created yesterday to represent a very basic Shiny application. And you can see the repo name there, and fingers crossed it works. So yes, that's good. So what that did is it went away and it said to GitHub, can you give me a zip file that contains this Shiny app? Then it downloaded it and it executed everything in that Shiny app, which I think is really cool. So anyone using Shiny, there's a little function in there called run GitHub. So that's the code. You can run it on your own computer, and as long as your GitHub repo is set up correctly, then it will actually give you an app, which is amazing for reproducibility, compared with the Transport for London guys who didn't even know where the files that define their models were stored. I can just give someone a single URL, a single line of code, and they can execute, okay, in this case, a very basic application, but it's still potentially useful. So all we have here is the road network in a city, and I can select the different road type. So in future work, we are planning to take these kind of methods and build on the methods that we've developed in the UK context and apply them internationally. And I deliberately chose this city. This is actually Accra in Africa. So we have a project funded by the World Health Organization that is trying to understand how we can provide an evidence base for people who lack resources in terms of data that will help them plan for sustainable cities worldwide, which is a really exciting direction of travel. So R can certainly help. If you're interested on Leaflet Shiny integration, check out section 9.5 of our in-progress book. Also, we plan to be publishing the slides from the workshop, so just check that out, and that will become available. I don't need to talk about the code here. The other thing that I want to talk about quickly is just local routing, so and remote routing. So the code on the right-hand side here basically sends a request to a planning application, and it gives you a route back. And interestingly, I just experimented going from Budapest Airport to here, and on Google Maps, it's impossible to get a route for cycling. I don't know why, but they don't have cycling built in. So I used a route planning service created by cyclists. It's a non-for-profit tech company, and there's a library there called Cycle Streets that allows that to happen. So that just shows you the very basic technology, which is much easier to do now than it was a couple of years ago. So that's another example of this, and I'm just showing that you can actually extract quite a fine level the attributes of this route. So although the map isn't rendering, if I was a transport planner and I was, for example, trying to find a good route, create a good route from the city centre to a trip attractor, say the airport, I would focus on this little red area here, which has a very low level, perceived level of quietness. So that's basically it, and I'm going to end it there. So thank you, everyone, and safe walking, cycling, and maybe taking a rocket back home from where you came. So thank you.